welcome back to Algebra 1. I hope you guys are all doing well. While we go through this, just make sure that you guys pause the video at any time. I encourage you guys to do that, especially before you practice the actual problems. That way you guys can check your work and see how you're doing. Again, this is going to be up to you guys. So don't just let me spoon feed it to you, but actually try out these problems first and then check your work. Reference back as much as you guys want. These are videos. They're going to be up for as long as you guys need them for. So please make sure that you guys use them as much as you need to. Study with them, use them before the test, whatever you guys need to do. Send me emails at any time if you guys have any questions, if you guys need any extra clarification. I highly encourage that for you guys because, again, if you don't tell me, I'm not sure. I'm going to try and link some extra videos in here as well to help you guys out. I do miss you guys, so please make sure that you guys are staying safe. Make good choices while you're on this quarantine or whatever you guys are doing currently. Just try and be safe. And then this is the time when you guys are taking charge of your education. I'm going to put as much as I can into this, but ultimately it's up to you guys on what you do with this time and what you do with these resources. Please make sure that you guys try and do as much as you can with this. I'll try and make these lessons short because I am just going to be working through these. So just pause when you need to. That way you guys can go ahead and work. I'm just working straight through, so go ahead and keep that in mind as well. So, quick review. Go ahead and think back to when we were back in school back in early March and how we would deal with these types of problems. Now, if you need to pause the video to try this out first, please feel free to. So, we have the problem y equals 6.5 times 0.85 raised to the power of x. First, we need to identify whether it's growth or decay. Well, we recall that these are written in the form y equals a times b raised to the power of x. Now, if our b value is larger than 1, it's growth. If our b value is less than 1, it's decay. So looking at this problem, we actually have decay happening because 0.85 is less than 1. So it must be decay. For our growth or decay factor, that's just asking for our b value. So again, if it's factor, it's our b value being 0.85. The growth/decay rate of change. Now, this is the one that you guys had a little bit of trouble with. Whenever we see rate of change, we're dealing with the variable r. Now, if we recall, b is equal to 1 plus or minus r. We do plus if it's growth. We do minus if it's decay. So right now, we already know that's decay, so we're going to use b is equal to 1 minus r. And from here, we have 0.85, that's our b value, is equal to 1 minus r. We solve for r by subtracting 1 from both sides. We get negative r, because this negative doesn't just go away, negative r equals negative 0.15. To get the r value by itself, we just divide both sides by negative 1. We're left with r is equal to 0.15. But don't forget, these are always written in percents. Rate of change for exponential functions is always written in percents. So move our decimal place 2 places to the right, giving us r is equal to 15%. And then we just want to include that it's a decay right here, because we want to know whether it's a 15% growth or decay. So it's a 15% decay. Lastly, our initial value. That's just our a value. So our a value in this case is 6.5. So that would be our initial value. Now, it's also important to remember that this a value is our y-intercept. It's where we cross the y-axis. So that will play a very important role later on when we're actually graphing these. But we can always find the a value on our y-axis. Lastly, does the graph represent an exponential growth or decay function? So this was all number 1. For number 2, this is a new problem. So we're dealing with this graph right over here. Looking at it, it creates a J-curve. And as we can tell, as x increases, as we go further and further right with our x values, our y values increase. So that's showing that we do have growth here. As x increases, y also increases. Now, if we were looking at it and it was going downward, then that would be exponential decay. Now, this is one of the few rare times where we actually cross the x-axis with these. In all the other forms that you guys will be dealing with exponential functions this year, you guys will always see them not ever cross the x-axis. This is something that you'll see more so in Algebra 2, but I just want to make sure that you know that those do exist. So, Number 1 in our notes. Or actually, sorry, this is still review. Number 1, complete the table and write an equation for the function. Identify it as exponential growth or decay. So looking at this, as our x values increase, as our x values get larger and larger, we're going down this number line, what happens to our y values? Well, we can see that they're getting smaller and smaller. So we can automatically say that this is decay. Now from here, they give us all these nice points, so we go ahead and we enter the points in on our table. So again, we have -19, 0.3, 1.1, 2.333, repeating, or 1/3. Now, very important that we try and keep it just going in order, going up by ones for our x values, and then from our y values, we can determine what's happening there. So, looking at this, we can already tell our a value. Our a value is our y-intercept, so it's 0.3, so a is actually equal to 3 in this case. To find our b value, we need to determine what's happening in our y column. So to get from 9 to 3, we need to think about what number multiplies. Now it's very important that we're multiplying, not dividing here. If we divide, we're going to have issues. If you multiply, you're going to get it right every single time. And in cases of decay, we need to multiply by a fraction, a number smaller than 1. So to get from 9 to 3, we multiply by 1/3. Now if you're having trouble with that because you're like, oh, 9 to 3, I just divide by 3, you're absolutely right. We are dividing by 3 here. But remember, we can only use multiplication. So just put 1 over the number that you're dividing by, and you'll have your b value. So we know a is 3, b is 1/3. From here, we can write our function out. Again, our functions are written as f of x is equal to a times b raised to the power of x. We know a is 3. We know b is 1/3. So therefore, we end up with f of x is equal to 3 times 1/3 raised to the power of x. Lastly, we can't forget to identify it as exponential growth or decay. We know that we're decaying as x gets larger, y gets smaller. So we're just going to add in that's decay here. Oftentimes, this is commonly what's missed on the test. People forget to write whether it's growth or decay. All right, here's another practice problem. Something that I was doing over this long break for spring break. I started practicing making bread. Here's some ciabatta bread here and then jalapeno cheddar bread. And I was learning about the fermentation process of dough. So for dough, you put yeast inside some water and it starts fermenting. And it starts with a bacteria population of, well, in this case, for this problem, we have 2,057. As I used warm water to help the yeast grow, the bacteria increased to 12,279 in 1 hour. What I want to know is what is the percent rate of change of the yeast inside the bread, and I also want an exponential equation to determine how much yeast would grow in X amount of hours if the dough is not refrigerated or baked. Now eventually this dough is going to spread out over the top and it's going to foam over if I don't take care of it or if I don't feed it. So we want to make sure that we're not doing that. So to get started, we're going to go ahead and use the information that we have here. We know that at time 0, so our A value, we're at 2,057 bacteria. So A is 2,057 because that's our starting amount. That's our initial value. To find our B value, we need to make a little table. So we have X and Y. When X is 0, again, we're at 2,057. When 1 hour has passed, we're now at 12,279. So this short little table will allow us to find our B value. Now, real quick, is our B value going to be larger than 1 or less than 1? Well, the answer to that is it's growth, so our B value needs to be larger than 1, or else it's no longer growing. So here's our work for part A. What is the percent rate of change of the yeast inside the bread? So again, percent rate of change is dealing with the R variable. We want to write it out as a percent. So since we have growth, we use B is equal to 1 plus R. And so we go ahead and we do B is equal to 12,279. I take any value in my Y column and divide it by the number right above it in the Y column. So divided by 2,057. This gives us about 5.969, which is a very large increase. And I go ahead and I take that 5.969 5.969, and I plug it in for our b value in this equation. So 5.969, and it's written right over here. 5.969 is equal to 1 plus r. And again, we're using plus because it's growth. Subtract 1 from both sides. We're left with r is equal to 4.969. Again, we got to make this into a percent, so I take my decimal place, move it 2 places to the right, giving us 496.9% growth. I didn't add that in there. It should be right here. 469.9% growth just for that bread yeast. As for part B, write an exponential equation to determine how much yeast would grow in X amount of hours if the dough is not refrigerated or baked. So again, this is just going to be written in the form f of x is equal to a times b raised to the power of x, where I can plug in numbers a and b into our actual equation. So our equation should be f of x is equal to 2057, that's our a value, again we found that early on, times our b value, 5.969, which we found just by dividing one number in our y column by the number right above it, raised to the power of x. Again, x is just replacing time in this case. So if I want to say, I want to know how much bacteria is in my yeast after 2 hours, I plug 2 in for x, and it spit out whatever number of bacteria is there in 2 hours. All right, so today's lesson. That was all a review. Today's lesson is 13.3, graphing exponential functions. Learning target is 13.3. I can graph an exponential function from a table or equation. So again, we're going to be given tables, and again, we only multiply in the y column. We're going to be given functions. F of x is equal to a times b raised to the power of x, and then of course we plug that back in. And from here, we're going to be graphing today. So this is the end-all be-all of Unit 13. We've gone through tables, we've gone through equations. Now we're going to graph them. So, rapid review. Exponential equations are written in the form f of x is equal to a times b raised to the power of x. Now we are going to be using table functions, so I highly encourage you guys either have a calculator at ready. If you have a TI-30XS, one of the school calculators, here's the steps that you can follow. However, if you have like a TI-84 Plus, one of the graphing calculators, here are the steps that you can also follow. But if you don't have either of these right now, check out Desmos, or I'd highly suggest Calculate 84. This is a new app in the App Store for Apple phones. Calculate 84 is very, very similar to the TI-84 Plus. So as soon as you download it, you'll see it looks just like it. The steps for the TI-84 Plus, I'm just going to go through them real quick since you guys will have this app available to you. There are other apps available to this as well in the Android store, so keep that in mind too. So step 1, click the y equals button in the top left of the calculator. It's in the top left corner. Step 2, write in your function exactly as it's written. You don't need to include the f of x equals. It's already there. All you need to do is include the a times b raised to the power of x. Now, if you're having trouble getting this raised to a power, the symbol for that on the calculator is a caret. It looks like that. So that is your best option for putting in exponents. And again, your exponent will be the variable x. That can also be found in the top left area of the calculator. From there, after you write your function in, exactly as a times b raised to the power of x, you're going to click the second then table in the top right. So you're going to hit the second button, which is also in the top left, it's right below y equals. And then you're going to hit table in the top right. So it should highlight all the yellow buttons if you have a TI-84, TI-83, and table should be in the top right. It's right behind graph. From there, use your arrow keys to move up and down the table, and then you can fill out any table that you need. So keep that in mind. I encourage you guys, Calculate 84, very useful for you guys throughout all of this, and just going forward as well. So, you're going to go ahead and fill in the table below using your calculator, and then sketch the graph of the table on the grid provided. So, go ahead and pause the video if you need to, try this problem out. The function that we are dealing with is y equals 2 raised to the power of x. So get started on this one. First off, our y-intercept. If we recall, all these functions are written as y is equal to a times b raised to the power of x, where our a value is our y-intercept. Now, if we look at this, 2 is being raised to the power of x, so that must mean that b is equal to 2. What would be that missing number in front of the 2? Well, that'd be a 1. So, our y-intercept is the point 0, 1. If we think about that, if I raise anything to the 0 power, all that we get out of it is 1. Now let's say I plug in 1 for x. Well, 2 raised to the first power is 2. 2 raised to the second power is 4. And 2 raised to the third power is 8. Now, a little trick with dealing with negatives, especially in simple exponential functions like this won't always work, but yeah, something simple like this. Whenever we're going into the negative values for x, we go ahead and we just put whatever number we have for the 1 value put whatever 1 value we have, we just put that over 1. So if this was negative 1, well, I go over to where x is 1. See that y is 2, so our y value would be 1/2. Do the same with negative 2. Well, that would give us 1/4. With 3, well, we got 8 down here, so this would be 1/8. Now, I know that these fractions are going to be very difficult to graph, but just remember, they're just fractions of this first bar here. They're not going to go past this first bar on our x-axis. Our y-axis, they won't go past this first bar. So, we start graphing these. When x is negative 3, y is 1/8. When x is negative 2, y is 1/4. And again, I'm just kind of guessing where these would be. I know that 1/8 is smaller than 1/4. I know that 1/2 is bigger than 1/4, so at negative 1 we're at 1/2, so about halfway between these two lines. Next, when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And lastly, when x is 3, y is 8. Again, these are just ordered pairs, x, y. Move 1 on our x-axis, up 2 on our y-axis. Move 2 on our x-axis, move up 4 on our y-axis, so on and so forth. Now we'll know that we're doing this correctly because it creates a nice J-curve for us, as we can see. And we are also not crossing the x-axis. Very important that we're not crossing the x-axis either. So from here we can go ahead and just graph this. We know it's growth because our b value is bigger than 1. We can also see that we're just multiplying by 2 each time. So 1/8 times 2, well, that just gives me 2/8, which if I reduce is 1/4. 1/4 times 2, well, that'll just give me 2/4, which is reduced 1/2. 1/2 times 2 is 1, 1 times 2 is 2, so on and so forth. So this does create a nice exponential function for us. Now, fill in the table below using your calculator and then sketch the graph of the table of the grid provided. We already did that. That was part A, as we just saw in the last slide. What is the y-intercept of the function? Well, if we look back here, we notice that our y-intercept was the point 0, 1. And we can see that in our table as well. Our y-intercept is 0, 1. So we can say that 0, 1, our a value is 1, our b value is 2. Is there an x-intercept? If so, what is it? Very important that we realize that there are no x-intercepts in any of these. Any exponential function does not have an x-intercept while we stay in Algebra 1. When you move to Algebra 2, there will be some, but just know for right now, there is no x-intercept, ever. What is the domain and range of the function? Well, domain is all of our possible x values. And if we remember, we just move across and make this J-curve, right? So if that's the case, we're including all these x values. And those arrows that were included show that it goes onward forever and ever. So even though it looks like we're kind of reaching a certain point where we just stop going up with our x values, we continue going over forever. So our domain would be from negative infinity to positive infinity, or all real numbers. Meanwhile, our range talked about how we don't have an x-intercept. So that's the smallest value that we can go to is 0. Meanwhile, our y values, we see that they get very, very large very quickly. Our y values move towards infinity. So I'm using these parentheses here because we don't touch those values. We never touch infinity. And again, we don't touch 0. We get very close to 0, but we don't touch it. Would you characterize the function as increasing or decreasing, and why? Well, as our x values increase, what's happening to our y values? Well, they're also increasing. So therefore, I would characterize this function as increasing, because as x increases, y increases. Also, because the function shows growth. So as we can see, all these x values are included, and it does continue going over forever and ever in the x direction, even though it's going in the y direction much faster. And we don't touch that x-axis. Very important there. All right, example 2. So this one's very similar to example 1. This time we have the function y equals 1/2 raised to the power of x. Fill in the table below using your calculator and then sketch the graph on the grid provided. So go ahead and pause the video if you need to. Take a second to fill out your table, and then also try this problem out by graphing it. If you want to, go ahead and try the questions right below it, just see if you are getting those correct as well, but I'll be moving through that very quickly. All right, so for this one, our a value in this case is 1, our b value is 1/2, because again, our b value is whatever is being raised to the power of x. So looking at this, if our b value is 1/2, we know that we have decay. So this should look like a reverse of what we just saw, a j-curve going in the opposite direction, a backwards j. So we start plugging in our values. When x is -3, y would be 8. X is -2, y is 4. X is -1, y is 2. This is just the opposite of whatever table we had last time. So same type of thing, just opposite table. From here, we can go ahead and start graphing our points. So let's go ahead and do that. At -3, when x is -3, y is at +8. X is -2, y is 4. X is -1, y is 2. So on and so forth, and it creates this nice j-curve. Now remember, we're estimating these points, but we know that they're getting smaller and smaller, so I shouldn't see any points jump up ahead of it and be like this. There should be nothing like that in our graphs. It should just be a very smooth curve here. Now, as we approach our x-axis, do we actually touch it? No, but we get very, very, very close to it. And as you can see, well, 8 times 1/2 is 4. 4 times 1/2 is 2. So I'm just multiplying by that b value continuously. So keep that in mind as you're working through these. Letter A. We just finished letter A, so moving on to letter B. What is the y-intercept of the function? Well, looking at that, we saw there was once again 0, 1. So that is our y-intercept. Is there an x-intercept? If so, what is it? Well, no. Again, with all these functions that we're dealing with, there will be no x-intercepts. There will always be a y-intercept. There will be no x-intercept for any of these functions. So no x-intercept. Our domain, looking at that previous graph, our domain, well, again, that's dealing with the x values. The x values continue in both directions forever, so our domain is all real numbers. And our range, our smallest y value is approaching 0. It doesn't actually touch, so I'm going to use parentheses. So I go from 0 all the way up to infinity. And these parentheses are showing that we don't touch those numbers, we just approach them. We get very close. Lastly, would you characterize the function as increasing or decreasing? Well, as x gets larger, as I move further and further right on my x-axis, my y values get smaller and smaller. So this would be decreasing, because as x increases, y decreases. Also, we know it's a decay function. Your turn. Try and practice this one on your own. This one's a little bit more difficult. Use that table function on the calculator. If you try and just use the trick that we just showed you, where we're just flipping the numbers over, it won't work on this one. So actually try and use that calculator, and then sketch your graph out. Take your time, and be very careful with these fractions that you're going to be dealing with. And, go ahead and try and guess those. So as we plug those numbers in, we end up getting 3/8 when x is negative 3, 3/4 when x is negative 2, 3/2 when x is negative 1, 3 when x is 0, when x is 1 we're at 6 for y, when x is 2 we're at 12 for y, and when x is 3 we're at 24 for y. Now, if you need to simplify these a little bit, this is 1.5, this is 0.75, and 3/8, well, 3/8 is 0.375. So very small numbers once again. You're going to be estimating where they're at. If you look close here, I tried to get about 3/4 of the way up to that first bar when x is negative 2. When x is 1, I'm at 1.5, so I go up 1.5. And we have our y-intercept at 0, 3, as we can see. So at 0, 3, we have our x-intercept. Again, it should make a nice, smooth J-curve for us when we're graphing this out. So practice this one before checking as well. Go ahead and fill out B, C, and D on your own. All right, again, our y-intercept is our a value. Our a value is 3, so our y-intercept would be the point 0, 3. Our domain is all real numbers because, again, we're continuing. These arrows signify that's going on forever, and it's not just going straight up, it's still going to the right as we continue. In our range, again, we don't hit that 0, we don't hit that x-intercept, so we use parentheses. Our smallest value that we're approaching is 0, the largest is infinity. And then we characterize this as increasing because, once again, it's growth, and also as x increases, y increases. Here's a second practice for you guys. This one's much more difficult. So again, try and use that calculator. If you need to, just take each value, negative 3, plug it in for x, and solve. But if you can use the calculator, the graphing and table functions, I highly encourage that. All right, so this one is decay because our b value is less than 1. From here, From here, we also know that we can figure out each of these points. Now, again, 500 over 27, plug that into your calculator. 500 divided by 27 gives us about 18.5. 11.1 when x is 2. When x is negative 1, y is 6.7, about that. And then when x is 0, y is 4. Now, I don't expect you guys to get these exact single points all perfect and everything. But I do expect you guys to round these out, determine what it is based upon what you know. From here, when x is 1, y is 2.4. When x is 2, y is 1.44. And when x is 3, y is 0.864. Now, again, this makes sense because as x is getting larger, our y values are getting smaller, so it is a decay function. Go ahead and graph it. It makes that smooth J-curve once again. Be very careful with these points. Again, these are fractions of a bar, so they're not going up a whole bar or anything. Just go up a fraction of it. And it should still make this smooth curve for us. What is the y-intercept of the function? Well, that's our a value. A is 4, so our y-intercept should be 0, 4. And as x increases, as x gets larger, we're moving more to the right. Y decreases, it gets smaller, so we say that's decreasing. All right, lastly, go ahead and try out practice number 3. For each of the following exponential functions, give its y-intercept and tell whether it's increasing or decreasing. So again, our y-intercept is our a value. So in the case of a, our y-intercept is 0, 8. And since our b value is less than 1, it's decreasing. For letter B, our a value is 125, so our y-intercept is 125. Our b value is greater than 1, so it's increasing. For our final one, our a value is 56, so our y-intercept is the point 0, 56. Our b value is 3 over 2, which is 1.5. So that's larger than 1, so it must be increasing as well. So again, increasing means growth, decreasing, decay. As for your homework tonight, that will be available on Schoology, 13.3 homework. that will be due tomorrow. Make sure that you guys study this up. Make sure that you guys are feeling comfortable. Of course, if you have any questions, let me know. Use this video as much as you guys need to study. Other than that, I look forward to seeing you guys soon. Take care, be safe, and I'll talk to you guys.